Today we're going to prove a very simple trig identity and learn how to use it. So we want to prove that sine squared of theta plus cosine squared of theta equals 1. So first let's draw our axes here, and let's draw any old angle theta right here. And we know that in our unit circle, if we use our unit circle, this is going to equal 1. So we also know that this is going to be cosine of theta, since this is 1. And then this right here, this length right here, is going to be sine of theta, since the hypotenuse is equal to 1. So now we want to recognize that this right here is a right triangle, so we can use with it the Pythagorean theorem. And we're going to say that cosine squared of theta plus sine squared of theta equals 1 squared, so 1. And so there we have our identity. So let's try a few examples using this identity to solve problems. So if we start off with a simple one, we're going to take sine cubed of theta plus sine of theta times cosine squared of theta equals 1. We're going to take that, and we're going to think about how we can solve this and make this, or at least make it simpler, with this identity right here. So if we see both terms on this side have a sine of theta term. So if we factor out a sine of theta here, we're going to be left with sine squared of theta plus cosine squared of theta equals 1, just like that. And we know that this right here is going to be equal to 1. So we have sine of theta equals 1. And so now we can solve it using our visualization. Our sine of theta is going to be equal to 1 when our theta is going to be equal to pi over 2. Or if we add any multiple of 2 pi to this, we're also going to get our sine theta equal to 1, because this 2 pi is just going to send us another revolution around. So we're going to start again, and then we're going to go up pi over 2 and get that 1 with our sine function. So let's try a little bit more complex of a problem. Let's say that we have sine squared of theta divided by 1 minus cosine of theta is equal to 1 plus cosine of theta. So how are we going to solve this? Well, we want to multiply this denominator here by the conjugate. So 1 plus cosine of theta and 1 plus cosine of theta. So this is going to be equal to 1. And I should have said at the start, we are trying to prove that this side is equal to this side. So if we multiply this out, we're going to get sine squared of theta times the quantity 1 plus cosine of theta divided by, so we're going to FOIL this one out here, we're going to get 1 minus cosine squared of theta, and that's all going to be equal to 1 plus cosine of theta. So now what are we going to do? Well, we're kind of stuck here unless we know our trig identity right up there. And so what we're going to do is we're going to look at this again and think, what would happen if we subtracted cosine squared of theta from both sides? And what would happen is we would get sine squared of theta is equal to 1 minus cosine squared of theta. And as we can see here, we have a 1 minus cosine squared of theta right here in the denominator of this fraction. So we're going to substitute in, for this, we're going to substitute a sine squared of theta. So we have sine, can you see this? Alright, sine squared of theta, it's a really bad theta, times the quantity 1 plus cosine of theta divided by sine squared of theta. So we can kind of see how we're solving this problem here. because these two are going to cancel out, and we're going to be left with 1 plus cosine of theta is equal to 1 plus cosine of theta. So we have just confirmed through trig identities that this equation right here is true.